Hi everyone. So today we're talking about explicit formulas for arithmetic sequences. You may remember that yesterday we were talking about recursive formulas. And I did start you with this warm-up today. It should have been written on the board for you. So I'm going to run through this really quick. So it is recommended that you get an oil change after 1,000 miles and then every 3,000 miles thereafter. So if I want to write a recursive definition, remember I always want to start with that term 1. And what that is really saying is, when will I need to get my first oil change? Well, my first oil change will be at 1,000 miles. And then to figure out where all my other oil changes are going to fall, it would be previous term, so a sub n minus 1, plus 3,000 miles. Okay, so every 3,000 miles from there on out, I'm going to get an oil change. So my first 5 terms of the sequence, well, remember my first term is given for me up there. Okay, so my first term is 1,000, and then I would want to get an oil change at 4,000, add 3,000 again, so that'd be 7,000, 10,000, oh, that looks like a decimal point, and 13,000. Okay, so hopefully you were okay with that. Now I'm going to use this problem as a basis for kind of doing my next demonstration here. We're going to talk about how to convert something like this into an explicit formula, okay, instead of a recursive. And remember, the benefit of that is you can jump to any term that you'd like. Okay, so I'm going to again show how to calculate these 5 terms, but I'm going to do it in a way that is maybe a little bit different than how you would write it down, at least. For those of you who are doing this quickly in your head, this might be sort of the shortcut that you're taking. So my first term is just 1,000. So term 1 is 1,000. For term 2, I'm doing 1,000 plus 3,000. And notice right now I don't even really care about what that answer is. I just want you to see that that's how I would get term 2, is I did 1,000 plus 3,000. Well, then to get term 3, I'm going to take what I had for term 2, so that's 1,000 plus 3,000, and add another 3,000 to it. Okay, hopefully that makes sense, that I took what I had before, 1,000 plus 3,000, and I'm adding another 3,000, so that's going to give me the 7,000 that I had up here. Okay, so to get term 4, I'd be doing what I had in term 3, so 1,000 plus 3,000 twice, plus I'd be tacking on another 3,000. Okay? And then for term 5, I'm going to take what I had in term 4, so 1,000 plus 3,000 plus 3,000 plus 3,000. So there's my term 4, and then to get my 5th term, I'm going to add yet another 3,000. Okay? And if you added that up, you would find that that equals your 13,000. Okay, this right here is 12,000. The 3,000s all put together is 12,000 plus 1,000 is 13,000. Okay, so here's the pattern I want you to see. Look at what we did here. We had our starting value, so that's term 1. Okay, and remember up here, looking at this recursive formula, this is known as our D value. Okay, so when I look down here at the bottom, this first one's pretty straightforward. That's just my term 1. Okay, and I know it seems silly that I'm writing this again, but I'm going to. That's my term 1. Okay, in my next row, I did my term 1 plus my D value times 1. Okay, do you agree with that? That I took this was my term 1, my A1, and then I did 1 of my D value. So then down in my next one, I did A1, so my term 1, plus 2 of my D value. So I did my D value times 2. To get my next term, I did my A1 plus my D value times 3. And to get my next one, I did my A1 plus my D value times 4. Okay, and what I want you to notice there, the pattern I want you to see, is that this number is always one less than the term number. Okay, so when I'm looking for term 2, I did my D value times 1. When I'm looking for term 3, I did my D value times 2. Okay, so now try to stay with me while I generalize this. So I could say, in general, if I wanted to find term n, any term that I want to, I'm going to start with my A1, and I'm going to add my D value multiplied by 1 less than the term number, right? So if I'm looking for term 5, okay, I'm going to multiply by 4. If I'm looking for term 3, I'm going to multiply by 2. If I'm looking for term 100, I'm going to multiply by 99. And the way we show that is we say times the term value or term number minus 1. Now that's not a subscript like you're used to. That's just n minus 1. Okay? And then what we're going to be able to do is simplify that. And when we simplify it, we're going to have a linear equation. Okay? Now, after you've tried a few of these, I want to see if you can make a relationship between the actual numbers in the sequence and then the numbers you see down here. But for now, this is sort of the formula I want you to focus on. So make sure you have this written down for sure. Okay? And I think actually before I tackle this question, why isn't A1 the y-intercept? I think we need to do one of these examples so you can see where the y-intercept is coming from. Okay, because what you're going to be able to do is take this and simplify it, and it's going to turn out looking like a linear equation. But let's go down and do an example first, and then we'll talk about that y-intercept deal. Okay, so example 1 says find the 40th term of the arithmetic sequence. Okay, and I actually think before we find the 40th term, I'm going to add a piece to this example, and I am going to write an explicit formula. Now technically we could get away without writing the formula, we could just jump straight to the answer, but I want you to see how to write a formula for it, and then we can use the formula to find the 40th term. Okay, but I want you to see the relationship here. So if I write an explicit formula, I'm going to pull that formula up from a second ago that we just had. So we said a sub n equals a sub 1 plus d times n minus 1. That's going to be our kind of form that we work in, because that was the pattern that we identified a minute ago, right? That's how things work here. So our formula is going to look like this. A sub n equals, now my a sub 1 is going to be 100. My d value is what's changing from term to term to term, and you'll see that that's going down by 3, so I'm going to say that my d value is negative 3. Could have, by the way, just written that as negative 3, okay, instead of plus negative, but it's okay either way. And then n minus 1. Let's distribute this. So now I have a sub n equals 100 minus 3n plus 3. Okay, so all I did there was distribute this negative 3 in there. And now I'm going to combine this, and I'm left with a sub n equals, and I'm going to put this first. I hope that doesn't freak you out too much. I'm going to do that so it looks like slope-intercept form. Negative 3n, and then when I combine the 100 and the 3, I get plus 103. Okay? So this here is now my explicit formula for this sequence, meaning I can now plug any term number into this formula, and I can get the term. So to find the 40th term, I'm going to plug in 40. To find the 50th term, I'm going to plug in 50. Okay? So from here, I'm going to now take what I just had there. Let's see. I want to find the 40th term. So to find term 40, I'm doing negative 3 times n, which is the 40, plus 103. Let's see, that's going to be negative 120 plus 103, which I believe is going to come out to be negative 17. So term 40 is actually negative 17 if I kept this sequence going. Okay? Now, I did this piece for your benefit because you're going to have problems where it just says, write me an explicit formula. Okay? I could have used this formula here to get this answer. Okay? And let me show you how to do that real quick, just in case you want to take a shortcut there. So if I wanted term 40 using this formula with the blue star, I could say a sub 40 is equal to term 1, which is 100, plus my d value is still negative 3, but I could have gone ahead and plugged the 40 right into that n. So 40 minus 1, let's see, so term 40 is going to be 100 minus 3 times 39. And let's see, 3 times 39 is 117. So 100 minus 117 would be negative 17. Okay, so this over here, when I did this to give you the explicit formula because you are going to have to know how to write these explicit formulas. And then I used that explicit formula to find my answer, but I could also just use this. Okay, so this is going to be a really helpful formula to jump straight to that term. Okay, so I simplified it here so I could write it as like a linear equation, but I could just use this itself to write it as an explicit formula. I'm sorry, to find the term. Okay. All right, let's look at example 2. Example 2 says the third term in an arithmetic sequence is 53. The sixth term is 41. Write an explicit formula for this sequence. Okay, and some of you might be able to reason this one out. Some of you might be able to do this on your own. You might, kind of do one of these things where you say, all right, I have term 1, term 2, term 3 is 53, and so on. Okay. If you want to do it that way, if you're able to do it that way, knock yourself out. But here's what I'm going to suggest to you. Remember that in an explicit formula, you're relating the term number to the term, okay? So you are saying term 5 is 12, and then so 5 comma 12 would be like a pair of numbers that goes together. So I'm going to pair up this information and treat it like a coordinate. I'm going to say 3 is paired up with 53, and I'm going to say that 6 is paired up with 41. And then I'm going to treat this just like a linear equation, okay? I'm going to start by finding the slope. So my slope here, 41 minus 53 over 6 minus 3. Well, let's see, 41 minus 53 is going to be negative 12 over 3, which is negative 4. Okay, so there's the slope of my line. And then I would need to solve for my y-intercept, right? So I would say y equals, and I'm going to go ahead and plug in my negative 4 as my slope, negative 4x plus b, okay? And pick one of these, I don't care which one, to plug in for x and y. So I'm going to say 53 equals negative 4 times 3 plus b. That's really 53 equals negative 12 plus b. Add that 12 to the other side, and I find that b is equal to 65. So now I can write my formula as y equals, or I guess I should use explicit formula terminology. So term n is equal to negative 4n plus 65. So all I did is instead of using y and x, I used n and then a sub n. If you had written that with y and x, that would have been okay too. But now this formula is going to give me any term in this sequence. So you'll notice that if I plug in a 3 here, okay, the answer I'm going to get is 53 out of this. And if I plug in a 6, the answer I'm going to get here is 41. So this formula now gives me everything I need for this sequence. Okay, one more. Concert hall has 20 seats in the first row. Each subsequent row has 2 more seats than the row in front of it. So let's look at this information that they're really giving us. They're telling us that we're starting with 20 seats. That's giving us A1. And then each subsequent row has 2 more. So that's really telling you your D value. Okay? So let's write an explicit formula, and I'm going to use that formula from a second ago. So A sub n equals A sub 1 plus D times n minus 1. Okay, remember that from a minute ago? And so our explicit formula would look like this. A sub n equals A sub 1, which is 20, plus 2 times parentheses n minus 1. Okay? I'm going to distribute this 2. So I get A sub n equals 20 plus 2n minus 2. And then I'm going to go ahead and put the 20 and the 2 together, and I'm going to put the 2n up in front. So my final formula looks like this. A sub n equals 2n plus 18. Okay? And that's my explicit formula. So that would tell me how many seats are in the 5th row, how many seats are in the 12th row. Okay? Now, pay attention to this one. If the last row has 64 seats, how many rows are in the concert hall? So this is really saying, if 64 is our last term, what term number must it be? Because remember, our rows are our term number. Okay? Row 1 is term 1. Row 2 would be term 2. So I'm asking, if my term number is 64, what term number is that? That means that 64 is going to go in place of my A sub n, and then I'm solving for n. So watch what I mean by that. I'm going to go to this explicit formula that I wrote. So in place of A sub n, I'm putting 64. And then I'm going to solve to find out what n would have to be to get that 64. So let's take away 18. Take away 18. That's going to be 46 equals 2n. Divide by 2, divide by 2, and we get that n is equal to 23. That means the 23rd term is 64. So 23 rows before you reach 64 seats. Okay? So that's how that one would work. I do want us to discuss this y-intercept issue and what we were talking about a second ago. We'll do that when I come back, I think. I want you to try these on your own a little bit first. Remember to fall back on this formula a lot. A sub n equals A sub 1 plus D times n minus 1. And then remember where that came from. That came from how do we get each term in the recursive series. Okay? So homework tonight is Lesson Master 3.8. Do the best you can on it. We will answer questions in class tomorrow.